Sorry? Huh? You ready? Okay, Exponent Laws, Part 2. You got a page, is it 1 page ago? 2 pages ago? Okay. It's got all the rules there. There's nothing new here today. They're just a bit bigger, a bit more complicated, but it's all the same rules. You have product rule, which says, if I multiply with the same base, what do I do with my exponents? I add. If I'm dividing with the same base, what do I do with my exponents? 5 take away 2 is 3. Okay? There's also a power raised to another power. This isn't multiplying with the same base. This is a power to another power. I don't add, I multiply. That's basically it. The only other thing you had there was something about this. Okay? But that's very similar to this. The only thing we have to do from this to this is know that that 3 applies to everything in the brackets. Then we just do product law. Okay? That's x squared raised to the power of 3 times y cubed raised to the power of 3. So that would be x multiply 6, y 9. Okay? That's it. That's basically all the rules, except the one you're going to get tomorrow. We're going to get some negative exponents. Okay? But don't worry, that's not till tomorrow. All right. Part 1. 3 students are attempting to simplify this expression. One of these people is right. One of them, well, 2 of them are wrong. Don't yell it out. It says explain. We don't just want to go Janet or Laura or Harry. Okay, you're not going to get marks for that. It says explain using factors. Factors was the last chapter. Remember factors? What are the factors of 6? 1, 2, 3, and 6. What are the factors of x cubed? X, x, x. Okay? Think of it as repeated multiplication. First, can I rewrite this? What does it say in English? It says 3 times x squared times 5 times x cubed. Is that the same as this? Does that say the same thing? Yeah. Brackets mean multiply. I don't have to have anything here at all. What does this x do? Absolutely nothing. Okay, what do these brackets do? Nothing. Is that the same as this? 3 times 5 times x squared times x cubed? Yeah, I can rearrange them. A times b is the same as b times a, right? 2 times 3, is that the same as 3 times 2? Yes. Okay. If that's helpful, do it. Because now we can see that's 3 times 5. What's x squared? X times x. What's x cubed? X times x times x. That is 15. How many x's do we have? 1, 2, 3, 4, 5. Who's right? Kind of wrote over it, but Laura. Okay? Am I multiplying with the same base? Yes. You can add your exponents. 3 plus 2 is 5. Okay? 3 times 5 is 15. 2 of them have 15. Harry's way out to lunch. He added 3 and 5. There's no plus in here. Okay? So if this helps, what does that take me? About 6 seconds? If that's how you're going to get your mark, guys, you're going to do that with every one. Okay? Use factors to explain why I can do that. Well, the first thing I want to do is, I don't want to see this divided by. I want to see that divided by. Okay? What are the factors here? Okay, I'm just going to use repeated multiplication. So don't think, 1 times 2 times 3 times 6, that doesn't equal 6. How many a's do I have? 6. I got a 3 down there. How many a's? 2. Now how does that help me? What is 6 divided by 3? 3 goes into 6 2 times. What's a divided by a? It's 1. Don't say 0. Because we want to think nothing like it's gone. Well, nothing kind of is like 0. It's 1. Okay? Anything divided by itself is 1. That a divided by that a. It's 1. So I have 2 times 1. What do I have in the bottom? A 1. But do I need to write it? No. How many a's do I have left? 4. Check. I explained, I proved that 6a to the 6th power divided by 3a squared is 2a to the 4th power. I didn't use any exponent laws here. I didn't use quotient law. I just expanded it out and started hacking and slashing, crossing stuff out, okay? Because I know that's 1. But let's check. What is 6 minus 2? When I'm dividing with the same base, I subtract. Is that a to the 4? Yeah. And 6 over 3, that's 2, right? Okay. All right. Just lots and lots of examples. I'm not going to do every one, okay? Because you can watch me do 6,000 of these, just like driving, just like golf, just like volleyball. You got to do it if you want to know how to do it. You can't watch someone else do it. You have to practice it, right? These are just enough to get you started. That looks awfully similar to our first example. If it helps, do that. Okay? Put the numbers together. Put all the variables together. All the like terms, put them side by side. What's 4 times 2? 8. Am I multiplying with the same base? Yep. Add your exponents. Okay? That's all I can do. I got brackets. I got minuses. Oh my God, it's overwhelming. Look how confusing that is. Well, let's hope not. What do these brackets do? Anything? No. They might. If there's an exponent here, they would. But what's the exponent here? A 1. What's the exponent here? A 1. So those don't do anything. Okay, can I rewrite this like this? You know the answer is yes, right? Okay, what's negative 7 times 6? Negative 42. 8 times A12. Multiply with the same base. Add the exponents 12 and 8, 20. Okay? Let's skip that guy. 30 over 45. Just look at the numbers. Can I reduce 30 over 45? Remember in grade 4, y'all got it right. Now that it's with some exponent stuff, some b stuff, now you're going to get it wrong. It's no different. Split it up. That's 30 over 45 times B14 over B10. If that helps visually, then do it. What goes into 30? What goes into 45? Let's just start with a 5. 5 goes into 30 how many times? 6. 5 goes into 45? 9. Okay, can I still reduce that? Yep. Yeah, 3 goes into that twice. 3 goes into that 3 times. That's 2/3. What do I do with the exponents? I'm dividing. Do I have the same base? Then I subtract. What's 14 minus 10? Yeah. That's probably how your answer is. But again, that's the same as this, guys, right? 2/3 times b to the 4 is the same as 2 times b to the 4 over 3, right? I can put a 1 here and multiply those. That's the same thing, all right? Oh my God, 3 sets of brackets. You didn't teach me how to do that. Do I need any of those brackets? Is that the same thing? Yes, it is. They're all multiplied by each other. I don't need any brackets. 18, 3 A's. I don't care if you have 47 of them. It's all the same base. Add the exponents. What's 4 plus 5 plus 3? 12, right? Okay. I don't know which ones. Oh boy. Choices. Like terms. X to the 5th times x to the 3 is x to the 8. Same base, add. Y. What's 8 plus 4? 12. Now, you get something like this. How many ways are there to do a question? Lots. Okay? Here we only don't have too many choices, actually. Okay? All I can do is divide these two. That's the same base. Right? X fifth over x cubed. 5 minus 3 is 2. Y, 8 minus 4 is 4. I was thinking of a different question. We're getting to it. Okay? So, you got to look. Do these brackets make a difference? You have to see. If there's a 2 there, then yeah, it does, right? Because this 2 applies to everything in the brackets, but we're not there yet. These brackets do nothing. Take all the numbers. Just do the numbers. What's negative 3 times negative 4? Positive 12. I have a b here times a b cubed times a b squared. How many is that? 3, 4, 5, 6. Right? Don't forget the b to the 1. How many c's? 1 there, 2 there, 1 there. 1 and 2 is 3, and 1 is 4. Okay? Just do one at a time. Again, if it helps, rewrite it out. Just rearrange it. Okay? All right. What now? What now? Oh, now we got this exponent outside the brackets. How joyous. Does this 3 apply to the x squared? Yes. Does it apply to the 3? Does it apply to everything in the brackets? How many times have I said everything in the brackets? Probably about, yeah, maybe I'm getting in double digits. Well, it's going to be 20 before the test, okay? Because it doesn't matter how many times you say it, people will still not do it. That's 3 to the power of 3 times x squared to the power of 3. I'm writing this out twice. What is 3 to the power of 3? 3 times 3 times 3 is 27. Power raised to another power. Do I add these or multiply these? I multiply. Okay? That 3 applies to everything in the brackets. Here, everything is only 2 things. How many everythings do I have now? I got 3 things. That applies to the B. It applies to the A. It applies to the number. Negative 2 squared. A squared squared. B cubed squared. Everything. Okay? What's negative 2 times negative 2? 4. Positive 4. A 2 times 2? 4. B 3 times 2? 6. Okay? Any questions so far? This is the one I was thinking of. I'm going to do this 2 ways. First, with multiplication law, because look at the top. I'm multiplying with the same base. What do I have? 5 and 3 is 8. Okay? On the bottom, I'm multiplying with the same base. How many do I have there? Yeah, 2 and 1 is 3. That's step 1. Can I still simplify this? Yeah, that's quotient law. I got the same base, so 8 minus 3 is 5. That's one way to do it. Maybe your brain likes to do quotient law first. Let's look at the first two. Am I dividing with the same base? Okay, x3 over x squared is x3 minus 2 is 1. Then we look at the next two. x5 over x is x to the 4. Now we're going to use multiplication law. Multiply with the same base, add the exponents. Do I get the same thing? Most people probably do it this way, right? Because we like to read from left to right. We like to do that first before we start doing this. Because we're not Chinese. We don't read from the bottom right-hand corner up to the top left. Do you guys know they read like that? All right. So lots of ways to do these. When we get a couple questions tomorrow, maybe the next day, there's like 6 ways to do a question. But if you use the laws correctly, we should all get the same answer. Yep. Bottom up, I believe. I think so. Anyway. Well, okay. All right. What does this 3 apply to? The A, the 2, everything in the brackets. All right. I'm not going to write it all out like this. What's a minus times itself an odd number of times? What's minus times minus times minus? It's a minus, right? 2 times 2 times 2, a times a times a cubed, over y cubed times y cubed times y cubed. If I got a power raised to another power, I multiply these two numbers, that's y9. And that's all I can do. Okay? How many more do we need, guys? I want to show this one. They're getting bigger and uglier, right? How many ways do you think there is to do this question? I haven't counted. Several. If you see something big and ugly like that, if you can, trust me, simplify in the brackets first. Do you know why? Because otherwise we're going to get some big numbers. I got 4 to the 4th power times 3 to the 4th power all over 6 to the 4th power. How about we just simplify in the brackets first? Does 3 go into 6? Now I only have 2 to the 4th power. I would much rather do that than 6 to the 4th power. 4 over 2. Can I simplify that? 2 goes into 4 2 times. Okay? I'm going to rewrite what I have. All I did was simplify the number in there. Okay? That's the only thing I did. I didn't touch any y's, any x's. I just simplified. If you want to think to yourself too, here's the other way. What's 4 times 3? Over 6? You'll get the same thing. Okay? All I've done was the numbers, and I've already shown you 2 ways to do it. Okay. Now, can I simplify any more in these brackets? You probably want to do it. All right? X to the 6th over x to the 5th is same base, subtract because I'm dividing, 6 minus 5. Well, that's a lot nicer. Now take everything to the 4th power. What is 2 to the 4th power? 2 times 2 times 2 times 2 is 16. 3 times 4, y to the 12. 1 times 4, x to the 4. Okay? Now, if you really want to do that 4 first, I'm not going to say it's wrong. You get the same answer, I hope, but I think you see it'd be a lot more work, right? Be a lot harder. Okay? This, guys, you know, don't freak out. It might be like a bonus question on the test, okay? I don't see the point. You're not going to see something like that in the government exam. But remember, with these brackets, they can be confusing. I'll just do this one. Is this minus sign also raised to the 6th power, or is it just the a? Yes, it's in the brackets. What's a negative raised to an even number of times? Always positive. How about this one? So that's the same as this. Okay? Same base, subtract a squared. This answer is going to be quite a bit different, right? Because that's not applied to that 6th power. This one is, okay, so that one is going to be minus a squared. That one's positive, that one's negative, okay? And I already warned you, you're going to see something like that on the test, right? Okay, one more I want to show. Extension. Ooh. Exponent laws. What is all this garble? You already know how to do this. Are you dividing with the same base? Yes, you are. Then what do you do with your exponents? You subtract them. There's the exponent on the top, right? It's b to the power of 4x plus y. Subtract the exponent on the bottom, but don't forget brackets. If you don't put brackets there, you're going to get the wrong answer. So that's the only way this sign will become a positive. Okay? You're subtracting the whole exponent on the bottom. The exponent is x minus 2y. And can I simplify this? Yep. Minus x plus 2y. Collect all your like terms. What's 4x take away 1x? 3x. What is y plus 2y? 3y. And that's all I can do. It's the same rules. It's just the exponents are a little bit uglier. This minus applies to everything in the brackets. So minus, if you want to think of it as a minus 1, that's fine. Minus 1 times x is minus x, right? Minus 1 times minus 2y is positive 2y. Like I said, if you don't put the brackets there, this will stay minus and you'll get the wrong answer. Okay, like I said, you can watch me do another 1,000 more, but you're not going to know it until you do it. Sorry? What do you need for? Here? That's a really messy 3. Okay, 1 to 9 odd letters. If you want to go through and do that first, might be a good idea. 10, 11, and 13. Guys, I do have quiz written there tomorrow. I'm not sure yet. I might want all the time to do negative exponents. You might be a 2-3 question quiz, okay? I haven't decided.